We already talked about this finding the right ratio between memory allocation and time to run your Lambda function. There are different tools to help you with finding this right balance. The first tool is power tuning, Lambda power tuning. This is an open source project, so you can go to GitHub and use this tool. And this tool is essentially good when you need to understand. So you build like a new application, and you want to evaluate how much CPU power, how much memory I want to give to my function. And it is quite simple. It just takes the same function and runs it with different memory configurations, and then builds you a graph to show that, yeah, here's the dependency, and you can find maybe the best configuration option for each function. So it is more the tool to make like an initial assessment where's this sweet spot. But of course, you may also want to understand whether your assumption was right, and maybe get some more data and metrics from the functions which already in production environment or in some other environments. There's another tool which is called AWS Compute Optimizer, and it takes metrics from already running Lambda functions in your environment. And again, it analyzes whether you utilize the resources right, and gives you some recommendations that maybe there are some further optimizations for specific Lambda functions. And also there's another tool which doesn't work directly with cost, but it also gives you quite good understanding whether your Lambda function utilizes the resources right, or you need to change something. It is CloudWatch Lambda Insights. It is like an addition to traditional logs and metrics you get in your Lambda function. And of course, there are some language-specific optimizations. So, for example, if you use Java, probably I won't spend much time on each specific recommendation, because it will take a lot of time. But for Java, there are certain recommendations. For TypeScript, JavaScript, the additional recommendations. Of course, using like the latest SDKs, usually they're better performing and takes less amount of resources. For .NET, again, there are additional recommendations. Another quite interesting thing you can do, and this is probably the only thing which is not technical from my presentation, is that you have this compute savings plans. And those compute savings plans, they can be applied to Lambda as well. It is basically you pay upfront some money, or you commit to a certain amount of usage for different compute resources, not only Lambda, but they apply to Lambda as well. And you can just save by committing that, yeah, I will use those resources and paying upfront. Another quite good optimization you can achieve. Remember that you can run Lambda on different processor architectures, and we support a traditional x86, and for quite a while we support Graviton 2 and ARM architecture. And usually, if you don't use any specific x86 instructions, or you don't compile and depend on any specific x86 libraries, you will get a better performance, and you will get a better price for running your Lambda functions on Graviton processors. And again, especially if you are running not compiled runtimes like Node.js or Python, it is easy to switch and to test. If you're using compile like Go or Java, then you will need to recompile those binaries to a specific architecture. And again, another good thing is that for power tools, you can run, for power tuning, you can run on different architectures. And again, you can compare, for example, seeing that, yeah, Graviton gives me a better price performance characteristics for a specific function. So to summarize this part, first of all, what should you remember? So you need to understand the Lambda function lifecycle and remember when to optimize what, that you probably need to focus not on optimizing not all functions, because again, if it's a small application with like 1 or 2 functions, then yeah, it's maybe either too premature to optimize, or maybe you can optimize all the functions. If you're running quite big application with like tens or hundreds of functions, usually my recommendation, select like the most critical ones and start optimizations efforts with them. Of course, you as a developer, you own the code, and the more efficient you can write the code, probably the better you can utilize the resources and get a better price performance characteristics. Again, all architectures, all software is about finding the trade-offs. Again, don't do the premature optimization. Do it only when it makes sense. And of course, don't forget about monitoring, about getting metrics, and all that kind of stuff. And another quite important thing when we started talking about serverless applications, yeah, we focus too much, to my mind, on Lambda, and we focus too much on optimizing Lambda functions. And sometimes we forget that in reality, your application consists of more different services and more different technologies. And yeah, it is a variety of things connected in your application. And you probably should also spend more time understanding the whole application and maybe thinking about what other things can I optimize to get a better price and a better performance. Let's start with the most common one. It is logging. Who of you used CloudWatch metrics and paid a lot for that? Okay, then probably you already know about it. But let's focus about a quite new addition to Lambda. Now you have advanced login controls with your Lambda function. And they allow you, quite interestingly, now you can have one CloudWatch log groups for several Lambda functions. Because by default, when you create Lambda functions, each Lambda function will have its own log group, and also it will have like the life cycle of each CloudWatch group like forever, keep all the data forever, especially if it's like a test environment. Probably you don't want to keep the logs forever because you will pay for them. So you should configure some lifecycle policies and retention policies. But now with these log groups, you can even create less log groups. And for example, if you have like one application consisting of several Lambda functions, you can configure to log from all that functions to the same place. And now you have also more controls on what types of things you want to log in terms of debug or info or other log levels. And now you can configure to emit logs in JSON format in a structured way, so that then you can use CloudWatch to query those logs and to get some insights. But Another very important thing I already asked about producing custom metrics. Remember that there's an EMF format, and if you want to produce custom metrics, always use EMF. Don't use this one. Don't use put metric API. It's, again, a simple example. We have a Lambda function, and we want to produce custom metrics, and yeah, it is not that heavy loaded Lambda function with 100 RPS and yeah, with 1 gig of RAM and 200 milliseconds of duration. If you run this Lambda function producing metrics, you will pay around $1,000 for Lambda itself and 2.5 March for CloudWatch. Don't do that. Don't use put metric API in any case. If you use EMF, you see, you will pay $71. So yeah, it's a huge difference. So I still see some customers using this put metric. If you do that, don't do that. But another question would be, EMF is quite tricky to produce, so you need to write a lot of documentation and understand how to create this EMF format. Here's a great library to help you, which is called Lambda Power Tools. And it's an open source project created by AWS and supported by some folks inside our teams. And it has libraries for different runtimes like Python, TypeScript, Java, and .NET. And it's standardized on how you can produce logs, metrics, and tracing. So you can just import this library and tell that, yeah, I want to put some custom metrics, and it will automatically create this EMF format and log all the necessary data to CloudWatch. And it also integrates with X-ray, so you can produce traces, and there's even more functionality. So these three utilities are basics, and they supported by all the runtimes. Although there are additional things dependent on the language. For Python, there are more things because I think the team started with Python, but then they added other runtimes. So there are a lot of other things which help you a lot writing Lambda functions. So if you don't use Power Tools now, start from today. Who using Power Tools? Not that much. Start using Power Tools. You come on Monday, you start writing Lambda functions, use Power Tools. You will get a lot of benefits there. Of course, I mentioned retention policies. Maybe you don't need to store logs forever in CloudWatch. Maybe you want to put them in S3 at some point of time. So again, think when you need to do that. Another question, it's an easy one. Which is more expensive? Of course, running a Lambda function more expensive than not running a Lambda function. But then the question is how I can do that, how I can get rid of my Lambda functions. Let's look at some examples. The first example will be Lambda event filtering. So if you consume events from SQS, from DynamoDB streams, from Kafka, from Kinesis, there's an additional event filtering mechanism built into the event source mapping. And it allows you to discard unnecessary events. So it's a common practice. You consume events from SQS or from Kinesis or whatever, and then you need to process only a specific ones. So you don't maybe need to process all of them. So you write some if logic inside your Lambda function. But you can also put this logic now in the filter of event source mapper. And the good thing here is that now, if you use this filtering before invoking a Lambda function, essentially you will have less Lambda function invocations. And the best thing here is that this functionality comes free of charge. So you don't pay any extra if you discard all the messages. So using filter, you filter out those messages, you pay nothing if your Lambda function is not invoked. And only for those invocations you pay like normal for the duration and for the number of invocations of those Lambda functions. So it is quite powerful mechanism, and I again encourage you to use this event filtering when you want to invoke Lambda functions only on a specific events. Another common technique for such type of invocations, again, if you consume events from SQS, from Kafka, from Kinesis, you can also configure batching. And you can you don't need to invoke a Lambda function for each separate message, for each separate record. You can, again, configure the event source mapper who polls and gets all that messages out of SQS or out of Kinesis to batch them in a batches and then invoke only one Lambda function for a specific batch. And then you can also manage this ratio between memory and CPU, understanding that, yeah, if I get a batch of messages, I maybe increase a little bit the CPU power, and maybe I can process those messages in parallel, so I can spin up additional threads inside my Lambda function just to process those messages. And it can also be more effective compared to process each message separately. Of course, sometimes, especially we talk about REST API, you can introduce caching, and you can, again, probably you don't need to invoke a Lambda function for each invocation. Especially, there's a quite common scenario. For example, if you use API gateway with custom Lambda authorizers, so that you want to authorize against maybe a third-party IDP provider, and you run this custom Lambda function to do the authorization logic. Probably the typical scenario is that whenever the call comes to the API gateway, this Lambda function authorizer will be invoked. But again, maybe it's not the most effective way of doing things, because again, if it's more highly loaded function and it has been invoked frequently, the authorization maybe is not changing that much all the time. So if you authorize that once, maybe for, I don't know, 1 second, you can keep the same authorization, so you don't need to invoke this Lambda function all the time. You can cache the response from Lambda authorizer to API gateway, and again, you can set a TTL time for how long this response will be preserved. And I see quite a lot of customers don't do that, and when they switch on, they can save quite a lot on this custom Lambda authorizing logic. Of course, there might be additional functions which return the same result, and maybe they are some kind of idempotent functions, so that again you can use API gateway caching, built-in cache, just to cache those responses, so that you don't invoke the Lambda function each time. And there are additional things like CloudFront, where you can also cache some things, and maybe again with API gateway, you know, or maybe you don't know, there are 2 types of endpoints you can configure. It can be a regional endpoint or an edge-optimized endpoint. When you configure API gateway as an edge-optimized endpoint, it will automatically provision a CloudFront under the hood, so it may speed things up in terms of network connectivity, so that the clients, they don't go to the region, they establish TCP connection to the nearest point of presence of CDN. So, and then the connection goes through the AWS backbone. So sometimes it also speeds things up. Another quite common scenario is that still we have our Lambda functions and they implement different logic and this logic may be calling another Lambda function or orchestrating some things. And remember, when you run your Lambda functions, you pay for time. So the longer your function is running, the more you pay. And if your function is making a call to another AWS service, or it is making a call to a network service, and you wait for the response, you just pay for idle. So you just pay for this function waiting for someone else to do some job. So there are other services like step functions, which allow you to orchestrate things and to build, for example, if you want to build a workflow, orchestrate some functions, calling calls between them, you can use step functions. Again, a simple example, you wait for some job done, you can implement that as a step in step functions, and then it will be more cost effective because with step functions, there are two different types, and here it is also very important to understand because they differ significantly in terms of functionality and in terms of price model. There's a standard one, and for the standard, you pay for transitions. So if you have like a long workflow and you transition between different steps, or if you have, for example, a loop inside that workflow and you retry some things, for each transition, you will pay. While with Express, you pay only for the duration of the step function. But there's another differences. Standard may run up to 1 year. So if you have a long running process, for example, you want to orchestrate some long running thing, then you can go with a standard. If you're orchestrating some short running things, Express can run up to 5 minutes. So you can orchestrate some short running things in Express. Another thing, and again, depending on the model, sometimes you will pay much more for standard. Again, quite common example. You have a process and you iterate a lot through different steps. For standard, you will pay like $200. For the same workflow running as Express, you will pay $3. The good thing is that you can switch models to some extent between standard and Express. Although there are some limitations, standard supports more functionality, especially if it is more like calling some other AWS services and waiting for the response, or using a so-called task token when you want to delegate something to external party and wait once they do some things. Another thing I wanted to mention regarding step functions, I still often see that people use step functions this way. So they create a set of steps, but implement those steps as a Lambda function. If you don't run some custom business logic in those Lambda functions, remember that there are direct integrations. So if you just want to store something into a DynamoDB table or read something from a queue or do some other interactions with AWS services, there's a direct integrations. So you don't have to pay for those Lambda function invocations if you just want to interact with different AWS services. Another direct integration Maybe some people know, some don't. A common scenario, I have a REST API, and then I have this REST API to interact with different underlying AWS services. I put a Lambda function in between. Sometimes you can omit that, so you can use a direct integration between, especially if you use, for example, step functions. So if you automated things with step functions and you want to invoke a workflow, you can do that directly. Or you want to go asynchronous and you just want to put a message into SQS and then process it in a Lambda function. You can use these direct integrations and put events or messages directly bypassing an API gateway. And yeah, here you can invoke different services. But as I mentioned, the most common one maybe is using API gateway with step functions. So to summarize, again, of course, you need to focus on Lambda and optimize a lot of things with Lambda for your serverless applications. But remember that it's a bigger picture and you may spend more time on different other services. So, and make this process iterative. So evaluate your architecture, look maybe for different points and identify different bottlenecks, and then optimize them, repeat this process, so make it like a habit. Event filtering and batching is super thin, and use this thing because it's built in and you don't have to pay extra for it. Orchestration with step functions and direct integrations can save you a lot in terms of, again, not invoking those Lambda functions. Direct integrations for API gateway. So if you use Lambda as a proxy, maybe you can get rid of it. Again, you can use SQS or event-driven architectures, again, to decouple things and maybe to minimize workload to the downstream services. Of course, it's ever-going process. You should evaluate cost, performance, and optimization all the time. And of course, I didn't mention a lot about cost management tools due to time, and it could be another lecture or another presentation. But there are a lot of different cost controls in AWS, so remember about them, set billing alarms, set different thresholds so that you understand how much you spend, and if your spend goes high, then you don't overspend. And of course, we're here to help. If you have any questions, you can reach out to me or to my colleagues, and we are happy to discuss your architecture, to look into it, and provide different recommendations and insights. With that, thank you very much for your time. And yeah, we have time for questions. Yes. Can you please give a mic?
Can you maybe tell us more about the low latency runtime that AWS has in labs?
You mean this JavaScript runtime? Yeah. It's highly experimental, so probably I wouldn't recommend to go into production with this runtime. But yeah, it is quite interesting one. It is a project of one of my colleagues who basically created a new JavaScript runtime optimized for latency, and yeah, it shows quite great results. Almost the same if you run your Lambda function in Rust, but you can still utilize JavaScript, which is more popular and more well-known among developers. I would keep an eye on this project. It is an interesting one. It shows almost comparable results with compiled languages like Rust or Go. But it is still experimental, so probably not the time to go into production with that. But yeah, it has been developed, so yeah, we'll see how it goes.
Thank you for your presentation. I have a question about the websites that has inconsistent usage. For example, a website for student results. Usually you don't have anyone using it, or maybe 1 or 2 usage per day, but then you have specific days where the result is coming in, and you have a very high usage. At this time you have thousands per second. So what would be your recommendation for such cases?
Yeah, so first of all, the first question I would ask, do you have any anticipation when this spike will be? So yeah, if it is like a known event in time, then you can use provision concurrency for it. So you can use auto scaling, so you can scale up and create some number of provision concurrency units, so that you don't be affected by cold starts a lot. So at least to some point you will be using this provision concurrency. And then yeah, it will be the optimal strategy for such workloads. When you know the pattern, you can provision concurrency, use it, and then you can deprovision that once the spike is done. If it's more like an unknown pattern, then yeah, for sure, still when you go into production, you can make some assumptions that yeah, I will get this amount of traffic. So of course you will do some load testing before you go into production, so that you make sure that you don't hit any limits, because as Shin today told, each of these services has its own limits in terms of how much concurrent invocations for Lambda you can have, how much concurrent requests you can get to the API gateway. If you use Dynamo, there's another set of quotas. So first of all, yeah, recommendation is that make an assumption how much traffic you may get into this website. Do load tests to see that you won't get any quotas breached. But yeah, if it's a known pattern, then yeah, utilizing provision concurrency can be beneficial, so that you don't have a big cold start penalty in the beginning of this spike.
And is there a limitation for the provision, like how many times it can work?
What do you mean? How much you can provision?
Yes.
Again, there are some limits, but of course you can't provision more than the total concurrency of your account. By default, it is 1,000, but yeah, you can increase it by creating a request. So virtually, there's again no limit, but of course you will need to talk to AWS if you speak about maybe hundred thousands of concurrency for your Lambda function. Then yeah, for sure you will need to speak to ours. But yeah, if it's lower numbers, then yeah, there's usually no issues. Yeah.
Thank you for your presentation. I've got a question back on the part with paying for handler execution only. I assume that this is due to some sort of caching mechanism under the hood. So I guess my question is, if that's the case, what is the TTL of such cache?
TTL for
the cache itself.
For API gateway or for what?
No, the Lambda execution, where you explained that if you've got a side call to another service, keep it outside of the handler so that you only pay for the handler execution time. So this side call outside of the handler, I assume that is done through some sort of caching under the hood. So my question is, how much of a TTL does this caching?
Yeah. This is an interesting question in terms of that. Yeah, when we provision this runtime, then we don't kill this runtime immediately when you have like traffic coming in. We will reuse those runtimes for. It depends for how long. So we don't have any TTL or any SLA for how long we will keep Lambda ROM runtimes under the hood. It depends on the region, on the availability of resources we manage under the hood. For each different regions, it may be different. So there's no like an SLA for how long this Lambda will be kept warm. Usually, from my experience, you may assume that it will stay warm from 5 to 10 minutes. But again, it depends on many factors. So you usually you can't rely on this metric. So you usually, if it's more like something you want to persist for a longer period of time, you can't rely on the persistence inside the Lambda runtime. Then you need to use some external thing. If it's more like you still will use some connections, for example, you establish a connection, or you still need to use some parameters. So yeah, you can initialize them once and then reuse until this runtime is available. But yeah, for each request you will, here, I didn't mention that in this presentation, but you need to remember that for each request coming to the Lambda, there will be a separate runtime processing that request. So how much requests you will have at certain point of time, that means that we will provision additional concurrent Lambda invocations for that. So for each separate request, there will be separate execution runtime processing that request. So this is also to keep in mind. Yep.
Any thoughts on packaging functions as containers versus using the language runtimes? I mean, those zips.
Actually, it is also interesting thing in terms of cold starts and in terms of how fast we download code. If your package is really small, like less than 10 megabytes, then zip will perform better because yeah, it's easy to download. But with zip, there's a limitation up to 512 megabytes total, so you can't put more data into zip. If you want to put more, the only way you can do that is to use container runtime. But another thing is that if your package is more than roughly 10 megs, because right now we use different techniques under the hood, how we fetch and how we cache the data, we will get container images more than 10, 20 megs faster than zips. So it can be also another benefit. So yeah, that's right. Yeah, there was another question.
Thank you. So you mentioned briefly event filter during your presentation. So I wanted to ask for some specific use case, how would you implement it, just as a general approach? So let's say you have RDS, Aurora, with several databases in a cluster, and you want very specific changes in one table, like just one column gets changed to trigger a Lambda execution. How would you approach in that case?
Yeah, with Aurora, it's different because with event filtering I mentioned, we use our event source mapper, and it is like our technology we create for Lambda, which connects to, and it doesn't support Aurora, so it supports like a Dynamo DB streams and Kinesis, Kafka, SQS. So it just effectively polls something and then triggers a Lambda function. With Aurora, there's no like a built-in functionality to implement that. So if I'm to do that with Aurora, there are several ways I can do that. Probably I will trigger a Lambda function and then query the database to find the changes. Or I can also think that, yeah, if there's some kind of reader log or change log for Aurora, I can pull, and there are some third-party providers who can pull the events or changes out of from Aurora or some other relational database. And then, yeah, you can, for example, trigger or create an event and publish those events to EventBridge or to SQS, and then hook a Lambda function to deal with those events.
See, thank you.
So if there are no more questions, once again, thank you very much. I'm here around, so if you will have any questions you want to talk with me about serverless, reach out.